In the last video, we played around on Desmos a little bit and got the relationships between what happens when we change these numbers in the trigonometric function and how that affects the properties. This is a little more formal how it's all laid out here. And you notice it's for sine or cosine. So when we see a number out in front here multiplied, that's going to be our amplitude. Notice it says the absolute value of that is the amplitude. That's just a distance from the midline to the top or the midline to the bottom. If we see a number added on the end here, like a plus k, then that's going to be our vertical shift or our midline of the graph. When we see a number just like on a parabola, we see like x minus h in here, notice it's all factored out, a parentheses x minus h, that's going to be your horizontal shift. That's going to be the opposite. So, if we see x minus 3 in our equation, that means right 3 units. And then last little thing there, that a out front. So when we see that a out front in the cosine or sine, that's going to be the reciprocal of the scale change horizontally. So that leads us to how we find our period. And parent function has a period of 2 pi. So 1 over whatever that a is, so that'll be your scale change times parent function period 2 pi is what we get. And below is a little example. So if we get an equation, how could we determine what the properties of this are? And I usually just start with the simple ones. When I look at this, I go, okay, well, 0.25 out front, our amplitude is going to be 0.25 minus 3 on the end. The midline or the vertical shift of our graph is going to be down 3 minus 3. That's our midline. And then now we got this kind of mess inside, which needs to be factored out before we start talking about anything. So instead of 1/4 x plus pi over 2, we're going to write 1/4 factored out, x plus, and then just a little quick game you can play. If I factor out 1/4, 1/2 divided by 1/4 is what needs to be in here. So 1/2 divided by 1/4 would be plus 2 pi. And you can double check yourself here real quick. Just multiply that 1/4 back in. It still should be the same thing as we started with. 1/4 times 2 pi is going to give you pi over 2. So now we can finish this off, our horizontal shift. Our horizontal shift is going to be, so this is plus, so this is going to be a negative 2 pi, left 2 pi. And it's kind of interesting if you shift a graph, the period, you may not even see that it has been horizontally shifted. And then our period of our graph is going to be 1 over the a, 1 over 1/4 times 2 pi. So our period here is going to get 4 times bigger. So that's going to be 8 pi. And there's all our properties. And we can just real quick switch over to Desmos and check this out. And if we graph this on Desmos, we get this in the home area. So let's change the settings on this a little bit here. So instead of going up and down like it is vertically, let's just check in here and go from like what, -4 to, might start to look a little bit like a sine graph here. And we can actually see what's going on. Here's the maximum value, 0. Here's the minimum value, negative 2.75. The minimum's negative 3.25. That's a distance of 1/2. We said the amplitude was 0.25. That makes sense. Our midline should be negative 3. I should graph that and see it. Y equals negative 3. There's the midline of our graph. And then we can get the period off of this pretty quickly too. What you see here is half a period. So if we double that, that would give us the full period of the graph, 8 pi. And I'm just going to zoom out here real quick, and you can see one period is definitely 8 pi.